reproduction, because that was the first characteristic that we realized in our breeding program with John Harbo. It was a feature of these bees that was pretty obvious. It's what we selected for. Then in 2005, we discovered that the major mechanism of resistance in these bees was the removal of mite-infested pupae from cat brood, which is Varroa sensitive Hygiene. So then I've been sort of doggedly interested in what's the relationship between these two, the behavior of the bees and then mite reproduction. And last year at this conference, well, here are two hypotheses that sort of are floating around out there. So we're trying to relate reduction in brood infestation caused by hygiene to an increase in mite infertility that we see in the mite populations that's left behind after these bees have had brood exposed to them for a little while. So one way you could explain it, and this is what we thought was going on early, is that this bees will be explained, increased mite infertility could simply be explained if the bees are removing mites that produce offspring. That's the easy explanation. An alternate explanation is that simply the hygienic activity itself is somehow interrupting or interfering with mite reproduction. So how do you separate those two? Well, last year we showed you an experiment where what we did is we took mite-infested brood and we exposed it to three types of colonies: controls, which are commercial Italian, hybrid VSH, and pure VSH, for only 3 hours, a very short period of time. And during that time, these bees were allowed to do whatever they do, which is hygiene, and they uncapped pupae. And what you're looking at here are pie charts of those uncapped pupae that were chewed, only the ones that were chewed, because to us, if you're being chewed, you're being removed by these bees. So above the pie chart is sort of the number of pupae from about 8 to 10 combs that were exposed in each one of these groups. And obviously you can see the VSH bees are chewing a lot more pupae. What was important to us to look at is what are they targeting specifically mites that produce offspring, only the fertile ones. And if you look across those pie charts, there's no significant difference. They're targeting fertile ones and infertile ones in a 3-hour period of time. And we also, I'm not going to give you a lot of detail, but we also looked at the background infertility in brood that was not exposed to bees, and we found similar levels of infertility. So this told us that these bees are probably not targeting basically fertilize and removing them from brood. But I wanted to go back and look at some experiments I had done and haven't been published yet in 2005. Wanted to add more data and we wanted to look at the system 1 week after an exposure and see what the difference is. And so we report to you data from 44 colonies in which we took mite-infested brood, stuck them in the colony for a week, and then we look at the end, we look at the mite fertility, and we try and relate it to the condition of the cell cap. And what I need to explain here is that when hygienic bees open cells, they often uncap a cell and recap a cell, and they do this frequently. I've seen 3 uncapping events and recapping in a 60-hour period of time, to give you an example, with VSH honeybees. So in a week's period of time, some of these cells could experience up to 10, maybe a dozen uncappings and recappings. We really don't know. But we wanted to relate mite fertility to that event if we could. So how do you know a cell's been uncapped or recapped? You can simply look at the underside of the cell cap, and if the silk is complete, it was never hygienically disturbed. If there are holes that have been patched with this more granular wax, that's an indication that it was uncapped and recapped at least one time. And I'll just go ahead and tell you, in most VSH colonies that have had brood for a week, you can't see any silk, just a very thin thread. They're totally uncapped, and it's a very large hole. Okay.
For all cells?
No, not all, but most. I would say 90% if I had to, in many of the colonies. So that's the kind of thing. This is just to show you that these are VSH bees. Let me go back, sorry. This is the infestation rate. That means 15 mites per 100 cells going in. This is 1 week later. You can see the control bees did remove some of the mites, but of course the VSH bees have removed more. This is a significant difference. This is just to show you that these bees are doing the hygiene that we know that they do. So that's the reduction in infestation rate. More importantly, for a comparison of what's going on with mite fertility and cell capping, you want to make sure the controls are doing at least some recapping. And certainly they are. I mean, almost half, in control colonies, almost half the cells at the end of this that we sampled were recapped. This was significantly different. And here's what we're after is when we compare, oops, I keep hitting the wrong one. When we compare normally capped cells that were never disturbed to recapped cells in the control group, there's no difference in the average number of offspring per female. And we only looked at single founders mite families. We threw out anything multiple. You see the same thing with the VSH bees, but what was kind of surprising to me is this value here was much lower than this value. In other words, I was expecting that this would be about the same level as here if these VSH bees were not specifically targeting fertile mites. That if you looked at cells that were not being manipulated, you would expect if they're not targeting fertile mites, that should be higher. So what's going on here? Well, there's a couple possibilities. This could be lower, not because the percentage of fertile mites is lower, but that when fertile mites lay eggs, they actually produce fewer offspring. So that's the first thing I looked at. Did they produce fewer offspring? So this is just looking at fertile mites only. And again, in normally capped cells, there's no significant difference here. If a mite laid an egg in a normal cell in a VSH colony, it had a normal complement of offspring. So if they were fertile, they laid a full complement. That wasn't the difference. So I was scratching my head a little bit. I was starting to think maybe that initial hypothesis is correct, that these bees are selectively removing mites that produce offspring. Well, I decided to look at the data differently, non-parametrically. And it's a good thing to do this kind of thing sometimes, because what you realize is that first bar that said 1.6 offspring is really only representing 51 mites from 25 combs that were tested. I mean, that's all the mites. After looking at 10,000 brood cells, we can only find 51 mites that were in normally capped cells in the VSH colony, and that's really quite low. So when you look at it this way, certainly this is slightly more infertile here than here, but it certainly doesn't suggest when 2 to 1 of the mites found in normal cells at the end in a VSH colony, 2 to 1 were fertile with a full complement of offspring. To me, this difference doesn't really suggest that they're preferentially removing this group. There's a slight increase. It's not that significant. I think what's more interesting is what's going on when you look at just recapped cells. There's a much higher infertility in the recapped cells of VSH bees than in controls. As you see in control bees, these aren't different. But the difference here, to me, is very interesting. Why is the consequence of hygiene different for control bees and VSH bees? So one of the things I decided I would do is, well, what do the caps look like if you looked at the distribution of large, middle, and small recappings? And I was actually surprised. I was thinking that most of the caps with VSH colonies would be here, and that's certainly true. I didn't expect control colonies to have a very high level of large recaps, and they certainly do. So what do I conclude from that? I don't know. Here's what I think is happening. I actually think VSH bees are visiting more frequently. They're uncapping and recapping cells, and whatever they're doing, I think, is interfering with mite reproduction, and they do it more often than control colonies. That's what I think is happening. And so that's basically the talk. So in conclusion, I think that they're still not showing a preference for removing fertile mites. The high infertility is associated with hygiene itself. Probably this frequent uncapping and recapping is somehow interfering with mite reproduction. And it's different. The consequences of this uncapping, recapping is different for the two types of bees. And I think it indicates there's a higher frequency of uncapping or recapping going on in these cells. So that's it. Thank you. Time for questions. Yeah, exactly.
When you manipulate the mite reproduction, say introduce mites into cells that are capped, say 12 hours post-capping, so they're not going to have babies, and then another one 6 hours after.
I've actually thought of that in print. Certainly, I have thought of doing that, and I actually did attempt this once early on, and I haven't lately reconsidered it, but certainly that's the thing to do, is sort of load the deck. Know that you have infertile mites going in, or actually I've done this other thing. I can actually raise mites and know they're not mated. And unmated mites don't lay eggs. I've actually thought of this. I can raise them, you can lift a large nymph from her cell, immerse her in an incubator if she's unmated. Then you can put her back in with a sister that was mated. For example, you got two groups, a mated sister and unmated, put them in, but that's all painful sounding. I got other things to do. Marla.
I think it'd be interesting, but as I remember from that Gonzay paper when they looked at, I think the male moves up to the top of the cell.
That's right,
at some
feet.
point. It would be
Actually, I've actually looked at some data in the past. I didn't want to show it here, where I actually think male mortality might be higher after this hygiene, and that may be a contributing factor.
But that suggests that they're detecting the movement of the male.
Maybe, or they're just there. When you watch them in video, I've done a lot of videotaping of this behavior. They're probing a lot. They're dipping their proboscis and mouth parts down around the pupae when they smell something in there. They could just be nicking them. They're pretty soft, so.
That's cool.
Yeah.
Did you show different sperm numbers of male mites?
I didn't break it down by, not here, I didn't break that down. I just kind of total offspring.
But previously, I thought you showed mating. I thought you count the
Sperm count, yeah.
sperm count in females.
Yeah, that's before we knew anything at all going on here. And I kind of been trying to think of how to get those results back to hygiene, the sperm count data from what you're talking about. But,
Yeah.
There's more time for questions.
yes.
I don't know how to support this, but it seems as if the cells have opened up more often. Maybe the mites are responding to this really bothers them. They don't want to reproduce to keep opening up the cell.
Yeah, that's what I think is happening. But again,
Somebody keeps opening the door.
right, and the problem is, that's what I think is happening, but I haven't proven to you that they're opening the cell multiple times. I have it in other, using photography over, but I've only done it on a small scale. So I don't know for sure that's what's going on here. Certainly there's a lot of indications that that's what's going on, but I haven't proven it in any. Yeah, Liz.
I'm just wondering if you looked at, there seems to be in the Varroa resistant stock, rims that are augmented and raised. And it looks to be at the fertilized stage. What's going on there?
Well, usually when I see a raised rim like that, that indicates a frequent uncapping and recapping. And often, I don't know, you've probably seen wax moth. Bees chasing wax moth often raise it like that too when they're chasing wax moth larvae. When they reseal it, it's often raised. And I think it's because it's an attempt to move the edge of the cell back from the pupae to try and get at what's in there. And then when they're done, somebody recaps it and ends up having that bubbled rim to it that you're talking about. How are we?
We have more time.
Oh wow, I went way too fast. Yeah, exactly. And then
Is this capping and non-capping repeatedly associated with the mite infestation in the cell?
that's a very good question, and the answer is I think yes. Especially, well, I don't know about the recapping, but I know uncapping rate seems to be density dependent. So at mite infestations, 15 to 20%, you get a certain expectation of uncapping I've gotten. And as you get down to around, I'd say 5% of mite infestation, the visiting of cells drops. So I don't know what that means in terms of stimulus response to hygiene, but that's sort of what I see happening. Steve in the back.
Hey, thanks, Jeff. So do you think that you could use this as an assay for BSH behavior?
Boy, we had hoped so. We were trying to have a slick technique like Marla has for general hygiene. She can go in the field and do a free-scale brood, I'd say, and boom, you got selection. And Jose Villa and Bob and I tried, especially Jose, he was leading this, tried to use these kind of short things. What can we measure? Can we measure the uncapping rate in the field or an uncapping rate after a certain period of time? And none of that correlated really well with mite growth in the colony. So unfortunately, not really well. We can't use some of it.
But what about the proportion of those larger circles?
Oh,
So
boy.
58. So if you were to look at the cappings and look for the ones that had the highest proportion of
Yeah.
larger holes.
Have you ever tried to look at the?
Yes.
Okay.
No, we've never done that, and I'll let Jose do that, okay?
Okay, one more question.
One more, and then we'll go on. Yes, sir.
What about a genetic marker?
Yeah, thank you. Yeah, that's actually where we have molecular biologists that are working on this at Purdue and then within our own lab. So we're hoping, we're pretty excited and think that is where we're going. It certainly seems to be the future of breeding, we hope, and it may help us, especially with all these techniques that take time and finesse. Maybe the molecular biologists can help us speed things up.